All right, coming to you live from my basement. One more video about selection sort efficiency. Be curious to know what you guys think of this little video thing here. Creepy, good, strange. I have no idea. Uh, get a view into my world here in the basement. At any rate, we had figured out that selection sort was an n squared algorithm based on its timing, right? But I wanted to analyze the code a little bit. Just something like long term, I think is probably a good skill to have. Not sure how much they're really going to put this on the AP test, but it's probably good to at least have some thoughts. And they actually do, sometimes they ask you about how many comparisons it takes to run some code and stuff like that. So at any rate, here's the code, a rough sketch of it that we did in the worksheet the other day. And so what kind of happens is, if we try to break this down a little bit, is this first loop is going to run roughly n times, right? Because it goes through all the elements one at a time and selects them in, right? So technically it would run n minus 1 times because it doesn't, when you get to this last spot, it's already sort of in order. But this outer loop starts here and goes all the way down to right here and selects the minimum for each spot, right? So that's going to be just n comparisons, all right? Sorry, this is not working great. Okay, click. Oh, okay. I think we're back. All right. And so then inside of here, right, this little code here is this find the minimum. That's also going to run roughly n times, right? Because it checks all the other positions to find the minimum for the spot that we're on, right? So basically, because we have a loop inside of a loop, that's where we get the n squared. Okay, so in the most simple sense, this is an n squared algorithm, right? If you want to break it down even further and try and figure out how they get this, right? If you can actually figure this out, you are smarter than this Westfall, because I can't actually figure it out. I know for sure that it's n squared because it's loop inside loop, and that it's not exactly n times n because, right, this find minimum doesn't loop through every single spot, right? It just loops from the spot it's on till the end, right? So if I go back here and look at a sample array, right, when we are, say, here, right, the find min doesn't run n times. It actually runs one, two, three times, right? It compares this one to the other three in there. So, and then when it moves over, now it only has to do two comparisons, right? So that inner loop changes each time. Sorry, I'm struggling to click the right thing here. So this find min is different each time. But roughly it's going to be about half of n, right? Because the first time it's n and the last time it's like 1. And so each time it's about, like, overall the average, sorry, it should be about half n, right? Which is where I think that half comes from, right? Because on average, it's going to run through about half of the elements. In the beginning, it runs through all of them. At the end, it only runs through a few of them, right? So that's where I think the 1/2 comes from. And then as far as the swap items going on here, this is just 3 steps each time, right? It's not another loop, so it just is 3 times. So this runs 3 times, but it runs for every single time in the loop here. So this sort of adds 3n because 3 things done n times, 1 for each time in the loop up here. All right, so that's roughly analysis of it. And if you do it completely correctly, you'll get some formula like that. For me, the most basic is just it's a loop inside of a loop. So n times n squared. All right, hope that made some sense. And the AP test does ask you about, like, how many times, how many items get swapped and how many comparisons you do. And I'm actually going to show a couple questions here like that. So here's what it looks like on the AP test. We've got sort. It doesn't tell you which sort it is, but and it looks actually different than the code I had shown before. But basically, what they're doing is we have a loop here, and this little part, if you want to guess what this is doing, you could pause and think about it. But what this is doing, this loop is finding the min, and then what do you think is down here, right? Again, pause and think, what do you think these 3 lines taken together, what do you think those do? Again, hopefully realize that that's our swap data down there, right? So the questions, I can't get them all on the same page here, but it's going to say, assume that sort is called with this array, what will it look like after 3 passes through the outer loop? Okay, so basically, if we run this 3 times, what is it going to look like? So basically, we just have to say, what is it going to look like after 3 swaps? Right, so like the first swap would be, we'd swap the 6 and the 1. Right, so basically, you just kind of have to know, like you don't have to know what that code does specifically, as long as you can recognize that it's selection sort. Right, so now that one's done. Now it's going to run again, and it's going to swap those two. So 1, 2, 3, 5, 4, 6. And now these two are in order. And then it's going to run one more time and select them in for this spot, which is already in its right spot. The code still runs, but it doesn't do have to do much there. It would count as a swap, right? As weird as that seems, it would actually just swap the 3 with itself. Sorry, my eraser's not working there. Right? It would actually just swap the 3 with itself. So it still counts as a swap, even though it doesn't really change the array. So I think my answer then would be letter B. After 3 times through, it would look like that. Okay. And I should, oh man, because you can't see it. So at any rate, it says how many times will the expression by compare values and assign temp be executed, right? So if I flip back, compare values is comparisons that we do, all right? And then assign to temp is swaps. Okay, so this is saying to do the whole thing, how many swaps will we do and how many comparisons. Okay, and so to sort of analyze this, the swaps, hopefully this makes sense to you from the worksheet, is going to be 1 less than however many elements we have. So this is 6 elements. We're going to do 5 swaps. So it has to be either at this point B or D because there's 5 swaps. And then the comparisons, what happens is to put the 1 in place, you have to compare it against this, 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 and this. So, right, so that's 5 comparisons. Right, and then this first spot would be sorted, and then the second time through, when you place the 2, you have to compare it to all the other ones. So when I place the 2, I have to compare it to those spots right there, right? So that's 4 comparisons. And then when you place this 3, you have to compare it to all the other spots. You don't have to compare it to itself, but all the other ones. Okay, and then the next spot, there's just 2 comparisons. Last spot, there's just 1. Okay, and then at the very end, you don't actually do any comparisons because it's already in place. So the total comparisons you compare it to all the other elements that could be the min, right? And so you just sort of get this little formula. And I think if you add all those up, I believe that would be 15. Okay, so there's 5 swaps and 15 comparisons, letter B, right? So that's kind of what it looks like is you have to analyze the code on the test. You don't have to write it, but you have to analyze what's going on and recognize that this is actually selection sort. All right, hopefully that made sense to you. Thanks for watching.